So in this video, we're going to calculate net and total displacement by finding the area under a velocity function. So the example says, suppose a particle is moving along a line such that its velocity is modeled by velocity is equal to t cubed minus 8t squared plus 15t feet per second. So up here I have a velocity axis, and my velocity is a rate of change. It's being measured in feet per second. And then I have a time axis. And when I calculate the area under the curve over the interval from 0 to 5, I will get the net distance traveled over that interval. That's what the net change theorem said. The net change theorem said, hey, if you have a rate of change versus time, then the area under the curve over a time interval gives you the net net change that has happened. In this case, my change is a position change, so it's a displacement. And the idea is, if we were to integrate over the interval from 0 to 5, and we plug in our t cubed minus 8t squared plus 15t dt, we're really multiplying a velocity, which is measured in feet per second, times a change in time. So it's velocity times dt is just time, velocity times time. So feet per second times second cancels. And we're actually getting a change in position or change in the number of feet, and then we're adding them all up over the time interval. So we get a total feet, the total number of feet traveled over that distance. Notice that the velocity function on the time interval from 0 to 3 is above the x-axis. So when I have a positive velocity, I get a positive distance in feet. So I pre-did this in GeoGebra and got 15 3/4 feet traveled over the first 3 seconds. And then when the velocity is negative, my distance that I travel, so on the time interval from 3 to 5, my distance is going to be negative. So I got a negative 5 1/3. 0.33 is going to be a third. Negative 5 1/3 feet traveled. So if you want the net distance traveled, it's just the sum of the positive and negative distances. So if I were to do it just from the GeoGebra work, I would say, hey, I traveled between 0 and 3 seconds, I traveled 15 3/4 feet, plus between 3 and 5 seconds, I traveled negative 5 1/3 feet, and 15 minus 5 is going to be 10, and 3/4 and 1/3 will have a common denominator of 12. So it's going to be 3 times 3 is 9. This is negative, so minus. 4 times 1 is 4, so we get 10, and 9 minus 4 is 5 12ths feet as the net displacement, the sum of the positive plus the negative distance traveled. The net change theorem says that I can calculate this net distance by calculating the integral from over the time interval from 0 to 5. So if we were doing it, the net change theorem, if we weren't worried about needing the total distance, so if all we were being asked for was the net distance, which we aren't, but if all we were asked for was the net distance, because some problems only ask for the net, then the easiest way to do it is just use the net change theorem and evaluate the integral from 0 to 5 of the velocity function. So if we do that, we integrate t cubed, we would get 1/4 t to the 4th minus, and here we'd have 8/3 t cubed plus integrate 15t is going to give me 15/2 t squared over the time interval from 0 to 5. Notice if you plug in the lower bound of integration, it zeroes out all 3 terms, so I only need to worry about plugging in the upper bound of integration using the fundamental theorem of calculus. I'm going to get 1/4 times 5 to the 4th power minus 8/3 times 5 to the 3rd power plus 15, but 15 is really 3 times 5 over 2 times, plug in the 5, I'm going to get 5 squared. And then what I can notice is that a 5 cubed shows up in all three terms. So if I factor a 5 cubed out, that's going to leave behind 1 5 on this first term, so just a 5 over 4, minus, factor out the 5 cubed, leaves behind 8 thirds, plus 5 times 5 squared is 5 cubed. Factor out the 5 cubed, it will leave behind the 3 over 2. So I get 5 cubed is just 125 times. When I look at the denominators, I see that the common denominator would be 12. So I'm going to get 5 times 3 is 15, minus 8 times 4 is 32, plus 3 times 6 is 18. So I'm going to get 18 plus 15 is 33. 33 minus 32 is 1. I get 125 and a 12th. 12 will go into 12 once. 12 will go into 5 0 times. With 5 left over, I get 10 and 5/12 feet as the net change. And then when I look over at the two areas I added up from GeoGebra, I see that I got the same result. So if all I were asked for was part A, the net distance traveled, I would get 10 and 5/12 feet, where these negative 5 1/3 feet canceled some of the 15 3/4 positive feet that were traveled by the particle during the time interval from 0 to 5. The rub is that it's asking me for the total distance as well, and that's going to change how I want to approach this problem. So if I know that I'm being asked for both the net distance and the total distance, I know that the net distance is just the sum of the individual distances. So I got 15 3/4, and here I had the negative 5 1/3. So to get the net, just like we did on the previous slide, you just do 15 3/4 plus the negative 5 1/3. But to get total distance, or in other words, the gross distance traveled, we actually would take the 15 3/4 and add to that the absolute value of the 5 1/3. So we would get a larger number, saying that I traveled a further distance than what the net denotes. And I mean, this makes sense. If you think about starting at your home and then driving to work or school, and let's say that distance is 20 miles, and then you drive back home at the end of the day. This is really like driving negative 20 miles because you went back. Your net distance, if you drive from home to work and back to home, your net distance is 0. You're right where you started. It's like nothing happened. But your total distance driven that day would be 20 plus negative 20 is 40 miles. So that's the difference between net and gross, or net and total. So we would need we have to add the absolute value. We need to make this negative distance positive in order to get the total distance driven. And so we get 15 5 is 20, and we'll still have a 12 sitting here, but now it's going to be a plus, and it will be a 9 plus 4 is going to be 20 and 13 over 12, or 21 and 1/12. In this case, we're doing feet. Feet would be the total distance traveled. So in terms of an integral, what you would want to do is break this up into two separate integrals. An integral from 0 to 3 that dealt with the positive area, and then an integral from 3 to 5 that dealt with the negative area. And to get those zeros, one way that you could do it is take your velocity function, t cubed minus 8t squared plus 15t, set that equal to 0 to try to find where your velocity function crosses the time axis. And if we did that, we could see that we could factor off a t, which would leave a t squared minus 8t plus 15 equaling 0. And then we would get t times, we have a second degree polynomial. It looks like it factors as t minus 5 times t minus 3. And then evaluating that, we see t equals 0 is a solution, t equals 3 is a solution, and t equals 5 as a solution, or those are the numbers that zero out the third degree polynomial. So what you want to do is integrate from 0 to 3. You really want to calculate the integral from 0 to 3 of v of t dt, and that will give you the positive area right here, the 15 3/4, and then you want to calculate the integral from 3 to 5, the integral over which the negative distance exists of the velocity function dt, and that's going to give you the negative 5 1/3. Of course, you actually need to show the work on this. So one way that you could deal with this is you could say, hey, suppose I'm calculating the integral from a to b of my velocity function, which is just t cubed minus 8t squared plus 15t dt. Well, you need an antiderivative, so you would get 1/4 t to the 4th power minus 8/3 t cubed plus 15 halves t squared from any a to b. And then you could evaluate for the two specific intervals. You have a closed interval from 0 to 3 over which there's positive area. You have a closed interval from 3 to 5 over which there's negative area. Calculate those two integrals separately. So calculate the integral from 0 to 3 of 1/4 t to the 4th minus 8/3 t cubed plus 15 halves t squared. Evaluate that from 0 to 3. There will be some work to show, but when you get done, you'll have the 15 3/4. And then evaluate the other interval from 3 to 5. So take the 1/4 t to the 4th minus the 8/3 t cubed plus the 15 halves t squared from 3 to 5, the time interval over which you have the negative area, or negative distance in this case, the negative distance measured in feet. Show your work, show the arithmetic going on here. It's not too hard to do. And when you get done, you'll get the negative 5 1/3. And then to get the net, take the sum of those two values, and to get the total, take the sum of the absolute values of those two numbers. So that's how you calculate net and total change.